Welcome to the Tech Ed Podcast, where we visit with leaders who are shaping, innovating, and disrupting technical education. People who are not afraid to think differently, not afraid to try something new, all with the goal of securing the American dream for the next generation of STEM and workforce talent. Welcome back to this week's episode of the Tech Ed Podcast. If you listen often, you know that we love talking about advancing technologies. We love talking about, in the automotive sector, electric vehicles, hydrogen vehicles. We love talking about autonomous vehicles. You also know that we talk a lot about convergences that are taking place in areas like advanced manufacturing and in other technologies, convergences like the convergence between information technology and operations technology. We call it the IT-OT convergence. We talk in some cases about the convergence between art and manufacturing and how there's so many commonalities in those worlds. Today, we're going to talk a little bit about another convergence. This is the convergence between advancing automotive technology and mechanical engineering. This is going to be an absolutely fascinating discussion. I've been looking forward to it for some time. Our guest on this episode of the Tech Ed Podcast is Dr. Zoran Filipi. Dr. Filipi is the founding director of the School of Mechanical and Automotive Engineering at Clemson University. Dr. Filipi, thank you so much for joining us on the Tech Ed Podcast.
My pleasure. It's great to be with you, and I look forward to this conversation.
So we look forward to it as well. You've been working in the hybrid and alternative powertrain and cutting-edge mobility field for quite some time. I would love to hear a little bit of an overview as we start out of your career, some of your research interests, and how you got to be where you are in this great role at Clemson.
Yeah, so it's been more years than I care to admit, I guess. And I was always driven by this passion for vehicles and powertrains, especially early on IC engines. And the energy kind of, came from the desire to change the world for the better.
Great.
So I started with IC engine research, and my PhD involved some modeling of the combustion process to eventually create a predictive tool to study a system issue, turbocharging and downsizing for fuel economy.
Great.
This was a long time ago. But I think there is a constant from those early days all the way to today, which is basically to go from fundamentals. In this case, it's fundamentals of energy conversion or storage, all the way to the system level to show how would you make these technologies a reality. That's number one, how to enable them. But number two, really critical, what is going to be that ultimate potential? Is this worthwhile? Is this going to change the world for the better? What I learned over time, too, is that there is a long path from that early research and discoveries to technology. In fact, often it's about 20 years. But this is the role of the university, basically make discoveries and search for these new pathways to technologies that will change the world for the better. So more than 20 years ago, this desire and this knack, again, to combine the fundamentals and the system level led me into the hybrid electric propulsion area. And this has been very, to me, enriching and invigorating because I ventured into the new realm, kind of. Was an opportunity to learn new things with my students, to meet some of the new faculty, and honestly, to create some of those opportunities for convergence, where different disciplines kind of meet up, work together. And a constant has been, develop these predictive modeling simulation tools that allow you to explore this vast space that leads to new technologies. So verify some of the new ideas way before they are a reality, way before any hardware becomes available.
Sure. That makes so much sense. And it really, when you think about it, disproving a theory is almost as important as proving one, right? Because if we're going to invest all this time and energy and capital in a new technology and bringing that to market, and boy, that's way too late to realize that technology didn't work. So it sounds like a lot of this work is really around conceptual ideas and then figuring out what might be commercially effective down the road. I worked with a gentleman for a long time who was a prolific business and real estate investor. And one of his favorite lines was, "The money you make is in the deals you don't do." And so it's really, really important to do that that research on the front end. So as we move from some of the topics about research, tell us a little bit about the School of Mechanical and Automotive Engineering and how your research work has led you to say, hey, we should converge the world of mechanical and automotive in that type of a collaboration as well.
The idea for the school is basically to combine two departments with different strengths, right? Very complementary to create something new that will invigorate the unit, that will invigorate faculty in both departments when it comes to research opportunities, as well as enable us to develop a new undergraduate program, a new BS degree in automotive engineering. If we just mention the automation, right? The revolution really taking place in both manufacturing and on the vehicle side. It becomes clear that, modern vehicles, technologies like that, or manufacturing, are not only about mechanical engineering. As a mechanical engineer at heart, I have to admit that, right? So we have been preparing, and we have been part of the change, for years now on the COI Car campus, Clemson University International Center for Automotive Research. And this is where we started the pioneering program, a graduate program in automotive engineering. So until now, it was master's and PhD program. The whole idea is to prepare for that future and prepare the talent for the future, where you need multiple disciplines. You need skills. Students or graduates need to acquire skills in multiple disciplines, but also learn how to work with people from other disciplines, and also have an understanding of the system, complexities, integration, and basically with that, be prepared for the modern workplace. Be really prepared on day one for what's waiting for them and what the expectations are out there in the automotive industry. So in the School of Mechanical and Automotive Engineering, we are looking to capitalize on the strengths of the largest department, largest undergraduate program at Clemson in mechanical engineering. And of course, many pockets of excellence, many strengths in individual disciplines. And this forward-looking automotive engineering multidisciplinary program, which has the pulse of the automotive industry and is very much plugged into what is happening now, the transformation that already started, as well as the future, what we anticipate will be the future.
So when you're talking with students about engaging in this new undergraduate degree, what are some of the careers that entice them? So if I'm going to spend my 4 years at Clemson and then I'm going on to a career, assuming I'm not going on to graduate school, what are some of those careers? What gets the students really excited?
So what they can expect are basically courses as well as some unique experiences, right? So what we have learned over time, this is something very important for us here at Clemson. So students these young folks really crave opportunities to get their hands on some hardware, right? To be able to run some labs, for example, themselves. Just think of yourself in the test cell where there is this hybrid electric powertrain and there is a battery system as well. And, one of the team members is working basically on the thermal management, for example, of the battery system, but somebody else is working on the optimal control for the entire propulsion system. So just imagine yourself as a student coming in and bringing a piece of software, uploading and being able to see the effect of that, being able to see the results in terms of performance, efficiency, all the key attributes of the system. So what we are going to offer with this undergraduate program are the opportunities for the students seeking careers in automotive industry and dreaming now not only about the mechanical aspects of the vehicle, but also think about the software-defined vehicle as a context, right? Think about electrification and all the news that we have heard lately, including here in South Carolina, about the significant acceleration of this transformation. So the new gigafactories are basically going to pop up all over the country very, very soon. And therefore, the young generation now has a different perception about these future vehicles, but is equally excited as I was when I was a youngster about the prospect of working on these exciting topics and these exciting technologies when they graduate.
Fascinating. So it's sounding like, first of all, great hands-on experiences in the undergraduate program, which to me is really, really important. And then to your point, Dr. Filipi, just all of the different changes in the automotive market that are taking place in real time. And, when I was coming of age and going to school and working in manufacturing, the model was really, it was Ford, GM, and Chrysler, at least in the US. And then you had all these tier one and tier two suppliers and to that, to that kind of central automotive market. And now we've got so many different players, so many different technologies. It's a great time to be a student at Clemson University, especially in the engineering disciplines. We're going to enjoy watching those programs roll out in the future, Zoran. So really exciting to be hearing about the great things that are happening at the School of Mechanical and Automotive Engineering. Clemson also has a unique approach to graduate studies. We talked quite a bit about undergraduate, but graduate studies called Deep Orange. Tell us a little bit about Deep Orange.
Exciting topic. So it's a real pleasure to talk about Deep Orange. And this is where the credibility comes from when I talk about creating opportunities for undergraduates as well. When we spoke about the experiential learning opportunities in the new program or programs that we are working on now, it comes really from what we have done with Deep Orange. So early on, when the automotive engineering program started, it's less than 15 years ago, the curriculum was developed based on a lot of input from the industry. And this basically told us that, the students need to have strengths in some of the fundamental disciplines. But on top of that, understanding of the vehicle as a complex system integration, and how to work in teams to coordinate, eventually come up with a successful product in the marketplace. And guess what? There was no textbook for that. So it was invented here at Clemson. Dr. Paul Van Hovens at the time was truly a pioneer with the idea to create a simulated research and development environment, laboratory on campus, and take students through a complete product development process in 2 years.
Sure.
So if you think about it, try to imagine yourself as a student.
I can imagine.
Wide-eyed with all these ideas and desire, to learn about the vehicle dynamics, about electrification and propulsion, about software, about the automation, right? And then we put you in the classroom and you have to sit through the lectures and study. And you have to do that, okay? You have to do that. But imagine a chance to almost like in the second week after starting, beginning with your team a market study.
Wow.
To understand your future customer. And based on that, decide what should be these critical attributes of your vehicle so that you can, after that, really begin working on the design, ideation, go through the stages of the concept design, layout development, architecture, finally starting to design components, subsystems, complete vehicle. In the last 6 months, this program culminates in building a physical prototype.
Wow. That's got to be, that's just an amazing experience to have as you're considering, your career pathway. And just to draw another parallel, one of the things we hear so frequently from manufacturers as they're hiring, bachelor's degree engineers or even graduate engineers, we hear often, hey, they're really good with the math. They're really good with the computer science. They understand physics. They understand calculus. But, it takes us a while to get them to the point where they actually understand system integration, where they're comfortable, in that case, on the manufacturing floor. And it sounds like, just to draw a parallel in the automotive industry, if I'm going to be designing automotive components, automotive features, entire automobiles, having that 2-year experience of going start to finish from ideation to to testing and trial and error and then finishing with a prototype really mirrors exactly what those students are going to see when they get to industry. I've got to believe the feedback you get from the employers is quite positive in terms of what they're able to do when they begin their careers. Feedback
has been amazing from the employers. These students get snatched up immediately after they graduate, or actually before they graduate. They get a chance to learn by doing. They also have a chance during their 2 years here in the program to interact directly with technical managers from the industry. So what we have at this point, we have been discovered by all the major OEMs for each one of these projects, and we are now at number 15 already, right? So for most of them, we had the major OEM as a sponsor, right? From BMW to General Motors to Ford to Mazda to Honda, for example. And we have been discovered by all of these companies. So we do have a healthy competition for talent coming out of these programs between the likes of Honda or GM or Ford, BMW here in South Carolina. So they have a closest, I guess, insights, through many of the collaborations that we have with them. Volvo or Rivian and Tesla. So, we have been updating and modernizing, changing our curriculum. In fact, the latest is only 2 years old.
Right.
And students are absolutely prepared, for this new world of automated vehicles, software-defined vehicles, as well as the manufacturing that comes along with that. So the manufacturing has been transformed as well. And there is a significant, basically, content that they get, through the education here related to artificial intelligence, related to the robotics and automation.
So 15 cohorts have gone through this program, each one of them partnering with a specific OEM toward a solution for commercial use. Do a lot of these products and a lot of these solutions find their way to commercialization in automobiles?
It's a chance for OEMs to basically test out some of the ideas, some of the really out-of-the-box thinking and ideas over only a 2-year period.
For sure.
So very, very fast pace. And honestly, much cheaper,
right,
than it would be to do something like that, to do something in-house, But I think what's most valuable is also for OEMs, for our partners, to interact with students.
Mm-hmm.
Many of these projects had basically, the task was basically to come up with a vehicle for Gen Z, right? So the vehicle that might be in the marketplace in 2028 or 2035,
sure.
Right? And who would be better than the youngest people, right? These young people,
exactly,
to try to imagine that future, instead of us.
Absolutely, yeah. Taking the future consumer and putting them in the position of doing the research and the development now for a vehicle that they may be driving in 5 or 10 years.
I can highlight a couple of stories.
Okay.
In one case, it was a completely different architecture of the vehicle. This was basically compact vehicle,
sure,
compact size, but with different attributes compared to what was on the market at that time, right? The entire architecture, eventually, even the styling of the vehicle was something unusual. And about 3-4 years later, a product came out of that company, that particular OEM, and all of us here, and we were getting emails and telephone calls from the students. They were like, I recognize this.
Yeah, right. Wow, that's awesome.
Better, it's a fantastic validation, what the students have done, the students together with faculty. Another one, I can even be more concrete and tell you that a couple of the projects here, Deep Orange projects, basically anticipated this day, like exactly where we are today. The anticipation was we have to be prepared for this transformation and transition from IC engines to electrification. So the whole vehicle was conceived, the architecture of the vehicle, as a very flexible platform, so that the management can make a decision. 30% of the vehicles are going to have an IC engine, another 25 are going to have a hybrid electric propulsion, and the rest are going to be fully electric. And guess what? 5 years down the road, they're going to be autonomous as well, right? So students were able to kind of imagine all this, go through that, and come up with real solutions that basically you can see in the marketplace today. Because, the situation and the manufacturing, especially, the strategies for manufacturing are very different for something like BMW compared to Tesla, right? Tesla can just focus on a single architecture for electric powertrain, while a large, established OEM such as BMW has to think about transition, how to do it gradually, how to be very, very flexible in this. And this is something that the students have been working on here, already anticipating that future.
And then getting to that future when they get into the workplace. And again, whether it's working for an OEM, whether it's working in a tier 1 or tier 2 supplier, if it's working in an ancillary industry relative to the automotive industry, huge and incredible opportunities taking place at the School of Mechanical and Automotive Engineering. It's going to be really fun to watch that roll out in the future. It's going to be really fun to watch what's taking place at the graduate level, at the research level, as you get into new technologies. I read an article not too long ago. Elon Musk, who of course we all hear about and almost on a daily basis, had said that by 2030, you won't be able to buy a car that doesn't have that isn't able to drive itself, a new car. Basically, by 2030, we won't be able to buy a new car that isn't self-driving. He said we really have all of the hardware, smart sensors, and devices now on a vehicle. It's just a question of letting the software catch up with that. Is that where you see it? I mean, in 10 years, will we be all at least have the option of a self-driving vehicle and not have to operate our vehicles if we choose not to?
Right, we are marching in that direction,
right?
Definitely. And even today, we talk about software-defined vehicles because it's such an essential part of eventually what you get as a consumer and the experience of using that vehicle.
Got it.
What I observe at this point is actually a faster pace of electrification than complete automation of vehicles.
Sure.
Right. So significant progress has been made and continues to be made. A lot of the OEMs, of course, Tesla in many ways leads the way, are at level 3, right? So vehicle autonomy level 3, where you have these significant driver aids, and basically the vehicle can operate autonomously in the relatively controlled environment, or structured, let's put it that way, meaning an interstate or a freeway. But to go from that all the way to level 5,
right?
There is a big unknown there that we introduce, which is a human. What humans do, other humans around you, not only yourself.
Right. Sure. Absolutely.
While if you look at electrification, truly, we are past the tipping point right now. We are past the tipping point, okay? Because the change underway now is not only in the realm of research and development. This is now industrial scale. The change that we observe is maybe on comparable to the early years of industrialization, basically, in US and around the globe. Okay, because instead of some of those plants that were built 30, 40, 50 years ago, where you go from steel to some mechanical systems for different applications, now especially with that new Inflation Reduction Act and the strong desire to provide some subsidies if necessary, if need be, for onshoring, to make sure that we have on this continent manufacturing capabilities, for these technologies, and that we can build reliable supply chains. Now, almost every day we hear about a new investment in a battery plant, right? Electric drive lines and everything else that goes along with it. So just here in the state of South Carolina, over the past 3 months, there were announcements for a new battery plant that BMW plans to build. It's a $1.7 billion investment. Next to it is going to be Envision plant providing battery cells, basically, for battery packs. So on this same location, right next to the BMW vehicle production plant, there'll be complete production from raw materials all the way to electrified powertrains.
Fascinating.
Last week, there was an announcement about Scout. I don't know whether you are a fan of off-roading,
Sure. Yeah, a bit.
If you're a fan of off-roading, then you know the name, you recognize the name.
Sure.
So Scout electric vehicles will be manufactured here in South Carolina.
Huh.
And they approached Clemson already, basically telling us projections will call for about 4,000 new jobs, and
wow.
Those jobs are going to be engineering jobs. So, right there, even more motivation, and more energy getting into the education system.
Absolutely. It's such an exciting time. And so as I'm hearing you, the autonomous vehicles may be fully autonomous, level 5 may be a little bit further away. Electrification and electric vehicles obviously already here and is just going to continue to proliferate. Is that the prediction?
It's going to continue to proliferate. Commitments are made, significant commitments, and these projects underway basically mean that we are going to have here domestically, in US, production of energy storage, as well as complete supply chains, ecosystems growing, around these plants. And that's the only way to get to the goal of, if not by 2030, but by 2035, in some of the states, all vehicles offered in the market will have to be electrified. In some others, there will be a large percentage of fully electrified vehicles, right? So what now needs to happen in the meantime, and federal government recognizes that as well, that's my observation, are investments in infrastructure. So charging is the next,
Sure.
Until now, it was, okay, batteries, raw materials. When it comes to raw materials, there is an answer, by the way. The technology to recycle lithium, for example, and other metals, cobalt, nickel, that has been just developed just recently. Until now, I was wondering myself, where is this going? How are we going to come up? Yeah. But recycling is an obvious answer, and the technology exists already, right? There is a plant being built as we speak, for recycling as well. Yeah. Recharging, though, right? So large-scale charging infrastructure, that's our next challenge, I believe.
Absolutely. Well, it raises a couple questions, one of which is just our reliance on, offshore sources of precious metals. And certainly you mentioned, lithium and cobalt and so on. And so much of that is produced and mined in Asia and in China, particularly these days, really does leave us a little bit at the whims of the kind of the geopolitical atmosphere. If we are able to recycle those metals domestically and probably find new sources of them in the United States as well, that really starts to change the equation a little bit. You've got such an amazing background, Zoran, so many different experiences, so many initiatives that you've led. I can't let the podcast end without asking you a couple more questions. The second to last of which is, if I'm a technical college dean, I'm a president, if I am a university provost, or I'm a program director, or I'm a professor, and I'm really thinking about how do I increase the teaching of hybrid and EV technology in my automotive programs, what advice would you have for those educators in terms of how you got started and how they can get started, based in particular about all you've learned from, I'm sure, plenty of trial and error and success and maybe a few headaches along the way?
True. Everything you said, so much learned along the way in different ways. But I feel that we in academia, universities, technical colleges as well, have to be entrepreneurial, right? We have to be responsive to the market as well, And the market is basically the employment opportunities for our graduates.
It's refreshing to hear you say that, by the way. Continue.
Well, I feel that responsibility. The students come to us with high expectations, with dreams.
Yep.
With dreams and ideas, and we have to fulfill those expectations. We need to provide high quality education for them and experiences. That's one part of my answer, I think. Experiential learning as well, that will prepare them for this brave new world, that will prepare them, and help them develop that mindset that, whatever we do, say, as engineers, has impact on the society and has to answer some of those key questions, right? Has to address either challenges that we have, or maybe create something new that will enhance our lives, provide something better for all of us. So from mobility, to discoveries related to the medical side of things, by engineering and things like that. We want to work on things that matter, right? We want to work on things that will make a very positive impact on the society. So the answer to you is we have to basically recognize the expectations, the responsibility we have, okay, and work hard to understand the market, quote unquote, which means, talking to these young people as well, for sure. But also keeping the pulse on the economy, the industry, whatever might be the area where we are active. We talked a lot about vehicles and propulsion, but this applies to other areas as well. Different ways to do that. You do that through partnerships, collaborations, you organize workshops. Some of the data obviously is available from the government as well. So all of that needs to drive our agenda. And, when we recognize there is a change underway, we have to get ahead of that. Because we are producing that talent, for the next 10 years or 20 years or 30 years. If new courses are required, let's go ahead and do it. Let's just out what exactly is needed, and let's work on that.
That was a very, very refreshing answer. And I think that's going to resonate well with all of our educators. As you know, at the Tech Ed Podcast, we're all about people who are disrupting technical education, which in my mind includes certainly the world of engineering education. And you're a true disruptor just listening to the way that you think about the work that you do, Zoran. I have one final question for you before we end our time with you, which has just been a great conversation. It's a question we ask in one form or another of a number of our guests, probably all of our guests at one point in time. So if you could travel back in time and you could meet yourself when you were 15 years old, and you could give yourself one piece of advice to that 15-year-old Zoran Filipi, what would that advice be?
Matt, if I think about a 15-year-old Zoran Filipi with dreams and ideas and a desire and impatience, okay, to start working on that, to start working on those dreams, to make them a reality, my advice would be to think about what will be critical in your education. So the education of a 15-year-old to bring you to that point. And look for opportunities to talk to the professionals from that field to understand really what does it take, to get there. So really, there is no substitute for first kind of building that background in the academic disciplines, making right choices in school, learning about what are the careers that take you to where you want to be, that will allow you to work on these exciting new topics. And then after that, I think once you get to the college level, after that, follow your passion, follow your heart.
I love it. So Dr. Zoran Filipi has been our guest here on the Tech Ed Podcast. He is the founding director of the School of Mechanical and Automotive Engineering, reflecting on that 15-year-old version of you as somebody who dreams, has desires, and is impatient. Something's telling me that not much has changed in that regard in terms of who you are today, which is really refreshing. I love your views and your philosophies on higher education, on interdisciplinary programs, on following technology. It's just been a really fascinating and enjoyable conversation, Zoran, with you. And we thank you so much for joining us.
Likewise. Thank you. I enjoyed it too.
Thanks for joining us for this episode of the Tech Ed Podcast. If you haven't already, subscribe, leave a review, and if you like this episode, share it with a friend. New episodes launch every Tuesday, so listen in next week.